So in terms of today's session, it's worthwhile noting that it's going to be a very demo heavy session. We're going to cover off quite a lot of information in quite a short space of time. Okay, so with that being said, we may end up glossing over some of the technical aspects of how we put together and how things are working under the hood, as this is just an introductory session. So with that being said, let's take a look at what is machine learning. So machine learning is a branch of artificial intelligence, also referred to as AI, that teaches computers to do what comes naturally to humans and animals, and this is to learn from experience. Machine learning algorithms use computational methods to learn information directly from data without relying on a predetermined equation as a model. Now, the key aspects to take from here is that with machine learning, what we're looking to allow the computer to do is to learn from experience. And we're going to do this by allowing the computer to learn information directly from the data. But how can we benefit from machine learning in Power BI? Well, we can look at some real-time predictions, customer churn analysis, customer leads and conversion, and how to predict fraud. In today's scenario, we're going to take a look at how we can identify what a good lead looks like to a business. So in this instance, we have a fictional company, that is spending £3 million per year on purchasing leads. These leads will then go through the sales funnel that we can see here. First and foremost, receive a sales call, then get a follow-up, ultimately ending in either a conversion or a sale. Now, this company has quite a poor conversion rate, as we can see here, 4.3%. Now, with that being said, we obviously start with quite a large amount of leads, which then get funneled down into those that convert into a sale. Now, this is a common business problem. Obviously, we have a high lead spend with a low lead conversion. So wouldn't it be great if we could identify prior to purchase what a good lead looks like for this organization? The benefits of that would be a more targeted lead spend. So whilst we could end up spending less on high quality leads that we identify as having a high chance of converting, we could also spend the same amount but acquire more quality leads that fit our target market. And again, the benefit of this would be a higher conversion rate, falling into obviously a higher sale as well. Now, with that being said, first and foremost, we're going to take a look at how we can use machine learning to identify high quality leads within Power BI Premium. And we're going to do this by taking a look at how we can use machine learning within Power BI. So with that being said, as I mentioned, we have our fictional company. Our fictional company is a sales company, an outbound sales company that purchases leads, takes those leads to its sales team, and ultimately calls them. Now, with that being the case, we do have a data set from this organization available to us. And if you want to follow along, I'm just going to pop the link to this GitHub into the chat. As this GitHub repo holds all of the artifacts that we need for today's session. Okay. So with that being said, the first data set we're going to take a look at is our sales training data. So I'm just going to open this up in a new tab. Now, our sales training data is a CSV which holds customer attributes of historical customers. So these are historical customers that have either purchased with us or ended up not being a purchase. So we have some attributes available for this customer. We can see that we have their age, their marital status, their gender, their yearly income, their total amount of children, the number of children at home, their education, their occupation, whether they're a house owner or not, the number of cars owned, their state province code, their postal code, and most importantly, we have our buyer flag. So this is a true or false value that identifies whether this customer purchased with us previously or not. Now, we're going to use this sales training data set to train our machine learning model. With that being said, we have another data set, our prospective buyer.csv, which is our leads. Now, as we'll see, we just open this up in a new tab. Now, You can imagine this has been taken from a transactional system because we have a prospective buyer key and a prospect alternative key. We also have a first and a last name in this scenario, and then we have common attributes, so the likes of age, marital status, gender, yearly income, total children, and so on and so forth that we saw in our training data set. But as you'll notice, in this data set, we don't have a buyer flag. Now, as I mentioned previously, the reason for this is that this is our lead data. So these leads haven't actually gone through our transactional funnel as of yet. So what we would like to do is, based on our historic data, so this is our sales training data, identify common attributes that come together to common attributes that come together to be a buyer, to have a true result in this lead buying with us. And we want to be able to identify those common attributes within our lead data and to be able to predict on whether they will buy with us or not. So with that being said, let's jump directly into Power BI Premium and see if we can put together our machine learning model. So I'm just going to go over to the Power BI service, and in this instance I already have a premium per user workspace created, which is our sandbox workspace. So we're going to open that workspace up, and to get started with machine learning in the Power BI service, we want to create a new data flow. Okay. Now on my system, I generally have to click this twice, but it may work first time for you. So we'll go ahead and select data flow. Now what we want to do when we're creating our data flow is define a new table, because we want to have the data that I showed you previously, so our sales training data and also our lead data, so our prospective buyer data, brought into our data flow as a new table. So let's go ahead and add new tables. And then we'll be presented with a familiar screen, which is Power Query Online, and we'll be walked through the UI wizard for Power Query Online. Now, in this instance, as our files are CSV, the data source connector we want to select is our text CSV connector, and we want to go ahead and link to a file. So we just wait for this to load here, and whilst that does that, we can go back to our GitHub repo, to our sales training CSV, and go ahead and we're going to get the raw version, and we're going to copy that URL. And if we go back to our Power BI service, now we have our file path or URL. We're just going to paste that in there and go ahead and select next. Okay. Power Query Online will then go ahead and pass that file and present us back with a preview of the information within that file. Now we can see that in this instance, Power Query has identified that our first row is in fact headers and promoted those values to headers. And also we can see here that our data types have been correctly identified. We don't need to do any transformations to the data here, so we can go ahead, select Transform Data, and save and close. Okay, so this will have ingested our sales training data into our data flow, and we're going to go ahead and give that a name. So let's go. Okay, go ahead and click Save. And now we've created our data flow. We have our sales training data loaded into that data flow. Power BI will prompt you to ask if you would like to refresh now or set a refresh schedule. And for the purposes of this demonstration, we don't need to do either. So let's go ahead and add another table so we can get our lead data into our data flow. In exactly the same vein, we're going to go ahead and select text CSV as our data source. We're going to go back to our previously opened GitHub file, which in this example is our prospective buyer CSV. So once again, just remember this is our lead data where we don't have an outcome at the moment, so no buyer flag. I'm going to go ahead and get the raw version of this file and copy out the URL. Now we'll go back over to the Power Query Online, paste in our URL, go ahead and select next. And then once again, Power BI will just pass this file and present us back with a preview we can see that again our first row has been correctly identified as headers and our data types have been changed to suit. And we can go ahead and select transform data, and once again we don't need to do any further transformations at this point, so we can go ahead and save and close. Okay, so fantastic. Power BI once again will ask us if we would like to refresh or set a refresh schedule. Again, for the purposes of this demonstration, it's not something that we will do at the moment, so we can go ahead and select close. Fantastic. So now we have our sales training data and our prospective buyer or lead data ingested into our data flow, and we can go ahead and start to look at building our machine learning model. Okay, so we just click the machine learning model in the top left, and then Power BI again will give us a bit more further information as we're going through this wizard in how we're going to create and train our model, then improve it, and then apply it. So in terms of first creating and training our model, we're going to select training data. So this is going to be to select our base data to train our model, choose a model type, and again Power BI will try and help us to pick the best model with the goals that we're trying to achieve. We will then go ahead and train our model. So the model will train on our data and report back on its performance. We're then going to look to see if we can improve that performance at all by iterating and retrain. So we're going to evaluate, customize, and retrain our model until it's optimized. And then we're going to go ahead and apply this model so that we can bring our sales lead data through the model, applying the predictions to it. So let's go ahead and get started. Okay. So as part of this wizard, Power BI is going to ask us what we want to predict. And as we previously mentioned, what we're looking to identify is whether an individual will be a buyer. Okay, so to do this, let's choose a table. Now the table that we want is our sales training data, so sales training, and our outcome column is our buyer column. So let's go ahead and select next. Okay, now once again in the background, as we mentioned, as we saw previously in the wizard, Power BI is going to go ahead and try to recommend the best model for us to use to get our required outcome. Now we can see here that Power BI has selected a binary prediction model, which allows us to predict whether or not an outcome will be achieved. So in this example, as we're looking to predict whether or not an individual would be a buyer, this is the correct outcome. However, if Power BI had not selected the right model for us here, we would be able to go over and select a different model by clicking here. Now, when we do so, we're presented with two different groups of models, shall we say, so classification and regression. Within classification, we can look at a binary prediction model, which, as we previously mentioned, is to predict whether or not an outcome will be achieved. And this is typically used for the conversion or converting sales leads and the probability of a customer responding to a marketing campaign. And as we know, this is the correct model for us. We also can use a general classification model. So this is to distinguish between 3 or more outcomes. So examples of this is classifying credit card applicants into those who have good credit, bad credit, and for those that require further analysis. And then finally, we have a regression model available to us, which estimates a numeric value. So examples of this include estimating house prices in markets based on regional factors. Now, as we mentioned previously, the model that we want for today's session is the binary prediction model. So let's go ahead and select that. Okay, now we're asked if we would like to choose a target outcome. So what outcome for the buyer are we most interested in? Now, again, for our scenario, we know that we're looking to identify when the buyer is true, when it is a buyer. So once the label predictions have been applied to this report, we can go ahead and decide what we would like to label. If it is a buyer, we would like to call it buyer. And very simply, if it's predicted as not a buyer, we would like to call it not a buyer. Okay, we can go ahead and select next. And then Power BI will just go ahead, load that information into the model in the background, and then ask us to select the data to study. Now, again, as we are using Power BI Premium per user or Premium, then in this example, Power BI offers up to us a recommendation on which attributes, commonly referred to as features within machine learning, it feels has either a high or low correlation with the buyer. So here we can see that Power BI is recommending that we use the age attribute or feature, the yearly income, the total children, the house owner flag, and also the postal code to understand if an individual is going to be a buyer or not. Now, with that being said, although Power BI is not recommending that we select these columns because they have a low correlation with buyer, I'm going to go ahead and select those anyway. As I mentioned, for the purposes of the demonstration, this will become apparent once we get our machine learning model report generated. Okay, so I'm going to select all of the columns and we're going to go ahead and select next. Okay, now we're going to name and train our model. So for the purposes of this, I'm just going to call it Philly M model. Normally, when you're building out these type of solutions, I would always recommend adding a description, not only for yourself, but for other developers that may be working on this model in the future, and also for any end users that will have access to this model. Next, we're going to go on to our training time. Now, especially for myself, I find that the longer I spend practicing or training for a skill, the easier it becomes and the better that I get at it. Now, this is also the same for this type of machine learning model. Generally, the longer that we train the model, the more iterations it has to go through. It's allowed more time to perfect and tune the model and to present back more accurate results. Okay, so this maxes out at 360 minutes and the minimum is 5 minutes. Now, for the purposes of this demonstration, I'm going to set it for 5 minutes as opposed to 360 minutes. And then what will happen next? So within the background, Power BI will go away and use 80% of the training data that we provided to the model to go and train itself on. It will then use the remaining 20% of the data to test to get the prediction right for the accuracy within the report. So once we've selected all of these values, we can go ahead and select Save and Train. And that model will be applied, and then we can see just down here on this value here that our data flow is now refreshing. That will go away and refresh for 5 minutes and then come back to us with a training report. Now at this moment, I'll just pause briefly to see if there are any questions. Take a look at the chat. Okay. Excellent. If there are no questions, then we will continue. As I mentioned, that data flow and machine learning model will go away and refresh for 5 minutes. So for the purpose of keeping us on track, I will move on to a previously trained model, which has the same data within it, and show you what you would end up with next. Okay, so what would happen is once that data flow has been refreshed, we would come back to our machine learning models within data flow, and we would be presented with our training report. So let's go ahead and click on our training report. And now our training report is going to give us an overview of the performance and the training details that have come together off of the back of the machine learning model being created and run. So once this generates, I'll just take you briefly through. Again, we won't go through everything that's within the report. Some of them outweigh the purpose of this session, but just to give you more of an overview. Okay, so first and foremost, we're going to take a look at model performance. Okay, so as we mentioned, this machine learning model has been tested on 20% of the underlying records. So this is 1,563 records, and the model performance with the area under the curve, or the AUC observed, is 79%. Now, again, we won't go into too much detail on the AUC. What we are interested in at this point is our top predictors. So you may remember, I'm just going to click on See Top Predictors. You may remember that Power BI suggested that I didn't select all of the columns because there was a low correlation in terms of us predicting the outcome of our buyer. Now, the reason for this can be seen here. So we can see that some of those columns, for example, yearly income, total children, number of children at home, etc., aren't high on our top predictors by influence. What we have is our age, the marital status, and total children, which again are the columns that, or the features that Power BI recommended to us. Now let's go ahead and select age, and within the report, Power BI will give us a bit of a breakdown in terms of how age has an effect on our buyer. So we can see here that for this organization, generally our buyers are either 46 years old or younger, or generally within the 46 to 59 age bracket. Similarly, for marital status, they are generally a single individual, as we can see here, and generally the total amount of children that they have is 1. Okay, so we get a bit of a breakdown there, and we can go ahead and exit. Okay, now with that being said, we also have our precision and recall values and how they affect our actual prediction as well. So the two values that we're interested in this grid here, so for our predicted buyer column, we're interested in this top left value here. So this is showing us, in the model's performance, how many of the predicted buyers, so how many the buyers the model actually predicted were actually buyers. And similarly, in the predicted non-buyer column, the value in the bottom right is what we're interested in as well. So how many of the predicted non-buyers were actually identified correctly. Okay, now with this being said, again, I'm not going to go too in depth in terms of this session on precision and recall to protect our time, but as we can see, if we were to increase the precision just by moving this scroller slightly to the right, we would see the effect it has. So now the model is able to correctly predict our non-buyers to a higher degree of accuracy, but we've also noticed that the correct prediction of buyers has also dropped slightly. So with this, you generally need to play around with this with the model outcome to mind. Generally, I say to start around a 0.5, so in the middle of both precision and recall, and then obviously get to where your desired outcome is. Okay. Now, with that being said, let's move on to the accuracy of the report, so our next tab. And again, we're going to gloss over the cumulative gains chart and the ROC curve. And basically, what we're looking to see here is, so our model is our yellow line and how it's performing against our green dotted line, which is the ideal performance, and how it's performing against what would be known as a random guess. So we can see here that our model's performance is in between a random guess in terms of a prediction and in between the ideal as well. Now, finally, on our final tab, we can go and take a look at our training details. And if I just scroll back to the top, we'll get a bit more information in terms of how our model was trained. So we could see that we had 7,293 sample rows, of which 80% of those rows were used to train the model. Now, whilst the model was training, it performed 32 iterations of the underlying data to get its prediction, and we get a bit more insight into how that training was performed and which classifiers and algorithms it was using. And finally, we get a bit more information about our features. So what the feature was that was being looked at, and the detected column type, and any imputation that's being applied to that. Now, once we're happy that our model is as expected, we can go ahead and apply that model. Okay, once again, I'll just show you how to do this, as this is a previously deployed version. Okay, so once you go to apply the model, if you remember correctly, what we're looking to now do is put predictions against our lead data. So the table that we want to apply this model to would become our prospective buyer table. We would add a new column, which we can call it outcome. And as previously mentioned, we can go for our, this is our value in between precision and recall, which could be, in this instance, 0.5. If you are following this along, then please go ahead and select save and apply. Whereas, as I've mentioned, this has already been applied to my model, so I'll go ahead and cancel. Okay. Now, once you have saved and applied that, you'll be presented back to your table screen. Now, if you remember, initially we started off with just our training data and our prospective buyer, our lead data. We now have an additional 4 tables available to us. Now, our first table is our training data. So this is the 80% of rows. We then have our testing data. So this is the 20% of rows that we use to test the data. And we have the table that we're most interested in, which is our prospective buyer enriched prediction. And then we also have an explanation around that as well. So our model has now successfully ran, been trained, and been applied to our lead data. So how can we see how that's panned out? Well, let's go over to Power BI. Let's start a new report. And what we're going to do is connect to our data flow. So we'll just wait for this new report to load. Okay, so we're going to go to Get Data. And as part of the wizard, we're going to be given a list of connections. Now, in this example, as I mentioned, we want to use a Power BI data flow. Going to go ahead and connect to our data flows. Now, this will open up a connection to the Power BI service and to our sandbox workspace. Excellent. So we can just go ahead and open up our sandbox workspace. In this example, as I mentioned, we're going to use the previous version that's already been deployed. So let's go to ML Webinar Deployed. And the table that we're interested in, as I mentioned, is our prospective buyer enriched buyer prediction. Let's go ahead and select that. Now, once again, Power BI will just give us a brief preview of the underlying data. We can just go ahead and select Transform Data. And the reason I've selected Transform Data here as opposed to Load is I'm just going to show you the additional information that our lead data has been enriched with. Okay, so as we can see, our lead information is as it was previously. We have our keys, we have our first name, age, etc. Let's just scroll to the right-hand side. And we will just see that we now have some additional columns. Okay, now they do have the buyer prediction prefix, but we have the outcome, which is the value that we're interested in. This is the outcome of our machine learning model's prediction. So whether or not each of these leads would become a buyer as a true or false. We also have the prediction score. Okay, so the higher the prediction score, the more of a degree of accuracy that this prediction is actually correct. And then, as I mentioned before, we also have some additional information in terms of an explanation of why that prediction was made, which isn't really necessary for reporting needs. And we also have an explanation index. Okay, so with that being said, I'm just going to go ahead and close and apply this to load our data. Power BI will just pull that data in as part of the connection. Okay, it's loaded pretty quickly. And we're now able to go away and visualize our data. So let's imagine that we've ran our machine learning model. We have our sales team ready and waiting to be able to contact new leads. So let's go ahead and get those leads' first name, maybe their last name. And also let's go ahead and get our prediction column. So the outcome and the score. Just going to make this slightly bigger. Okay, and more readable. And we're also going to put in a rudimentary filter on the outcome. Okay, so with that being said, as I mentioned, we have all of our leads by first name, by last name, by their predicted outcome in terms of would this lead be a buyer, yes or no, and also the prediction score. Now I'm going to go ahead and filter this data down just to show us true predictions. So where our machine learning model has predicted that this individual would be a buyer, I'm then going to sort this by descending to identify those which have a more likely prediction, and this data is now readily available to be given to our sales team. Alternatively, if we didn't want or we had individuals that we didn't want our sales team to contact because they have a low probability of being a buyer, we can alternatively just filter this to be false, and once again we can just sort this descending to which is a more likely prediction. Okay, so in this demo, excuse me, we've looked in Power BI Premium or Premium per user how we can identify leads in their likelihood to convert, and very quickly and in a low code and really a no code environment as well. So we just jump back to presentation. Okay, that's great, but premium and premium per user does come with a cost. So premium per user is $20 per month, and premium is done on a capacity basis. So for some individuals that just have Power BI or Power BI desktop, or they have the Pro license, how can we get access to this type of functionality? Well, let's go ahead and once again make the machine learn. And as always, just be aware that no machines were harmed in the making of this webinar, even though he does look very tired and exhausted. So with this being said, actually, let me just go on to our next slide as well. Okay. So with this being said, we need to get some alternative tools. Okay, so what additional tools can we use for machine learning in Power BI without the use of Power BI Premium or Premium per user? Well, first and foremost, we want to get something called Anaconda. Now, those of you from a data science background may already be familiar with Anaconda, but it's basically the easiest way to spin up a Python or R data science or machine learning environment on a single machine. Additionally, once we have that environment set up, we want to utilize a library called PyCaret. Now, PyCaret is an open source and low-code machine learning library in Python, which allows us to go from preparing our data to deploying our model very quickly. Okay, so with that being said, I'm going to take you over to the websites that you probably need for this information. So first and foremost, I recommend, if you are following along, to go ahead and get the Microsoft C++ build tools and download those tools to make sure that you're fully up to date. And I'll just go ahead and pop that into the chat. Additionally, as I mentioned, you want to go ahead and download Anaconda, which can be done directly from their website as well. So just go ahead and download Anaconda. I'll just pop this link into the chat. Once again, in an effort to fit all this into a session, these tools have already been installed on this system. So once you have those tools installed, we want to create an environment that we can use within Power BI to enable us to use Python. So let's go ahead and take a search for Anaconda on this system. And we want to use the Anaconda prompt. So we're going to go ahead and select that. Okay, now once we've selected and loaded our Anaconda command line prompt, you'll notice that we're in our base environment, which is defined here. Now we want to create a specific environment or a container for us to build out our library and tools to be used within Power BI. So to do this, we need to use the activate command, and we're going to call this environment data science _ UG. I'm going to go ahead and select enter, and you'll notice that we've now switched to our data science _ UG environment as opposed to our base environment. Now that we have our environment or container, let's go ahead and start to install some of our tools. So to do this, we want to use the conda command, and we want to, in this instance, install pip. Pip will allow us to install other Python libraries very easily within this environment. Now this will go through very quickly, so if you are following this along at home, it might take slightly longer on your machine because this machine is already has pip installed. So once you do have pip installed, we can use the pip command to go ahead and install our PyCaret library. So to do this, we just simply type pip install PyCaret. Go ahead, select enter. Again, this may take slightly longer on your machine. We do already have the latest version of the PyCaret library installed in this environment. So as you can see, it's gone through and all of the requirements are already satisfied. So once you've completed that, you now have your Python environment all ready to go with all the libraries needed to start to be able to utilize Python in Power BI Desktop. So with that being said, we need to ensure that Power BI is correctly set up to use this Python environment. So first and foremost, let's go to open up a new Power BI file. And then once this loads, we just need to make a change to a couple of options and settings. So we don't need the wizard for this. We can go ahead and go to File, Options and Settings. Then we go to Options, Okay, and then we can go down on our left-hand global options to Python scripting. Now, as I mentioned, we've now created our Python environment. We need to make sure that Power BI is aware of this environment so that it can access the libraries that we require. So with this being said, we need to set our home directory to other and identify your Anaconda install and then your environment. And this in this case, we're going to use the data science _UG environment. Once you've browsed and selected that directory, you can go ahead and select OK. And Power BI is now all fully up and running to be able to utilize that Python environment. But obviously, to start using this environment, we need to get some data. So let's go ahead and get data. Now, this is where the process differs slightly from what we're able to do in the Power BI service. So previously, we used text CSV. Now, in this example, because we're connecting via Power BI desktop, we actually need to use the web connector. Okay, now very similarly, it's asking us for a URL. So we can go back to our repo. Now, if you remember, we're going to get our sales training data. We want to get the raw version of that so we can get our URL. Okay, just select back on that. I'm going to go ahead, copy and paste that into our URL, hit OK. And once again, Power Query would just go away and preview that data. Now, in this case, again, because we're using Power BI Desktop, it hasn't correctly identified that our first row is headers. So we're going to go ahead and need to do some transformations to this data set. Okay, so with this being the case, we're going to use our first row as headers. And then again, we haven't correctly identified our data types. We can see that they've all been classified as an any. So we could just very quickly going to go through and change some of the columns that we need, their data types. Now, once again, with an effort to stay on time, because we are looking to get through quite a lot of information in this short space of time, I'm going to be glossing over the majority of technical aspects of the underlying Python scripts, whereas our interest is just in the output for this session. Okay, so let's change these to be a whole number. Okay, and then let's go ahead and we need to get some more data now. We need to get our lead data. So let's go and get new source and get the information from our web, as opposed to text CSV. We're going to go back over to our GitHub repo, to our prospective buyer, so our lead data, go to the raw version, and once again, get that URL. Going to copy it and paste it in, select OK. Now, again, with this, Power BI will go away and parse the file. It has, again, in the desktop version, incorrectly been able to identify the first row as headers. And similarly, for the data types, they haven't been defined either. So we just need to use the first row as headers and just jump through and change where necessary. To use a whole number. It's type. Okay, so with that being said, we now have our sales training data and our prospective buyer data ingested into Power BI Desktop. So what we want to now do is start to build out our machine learning model. So to do this, as we mentioned, we're going to use Python and we're going to use PyCaret. So we want to go to transform on our sales training data and go ahead and run a Python script. Now, fortunately, all of the Python scripts we're going to use in this session are available in the GitHub repo that I mentioned earlier. And you can just go back to the root of that repo, and we're just going to run through these in numerical order. So first and foremost, we need to impute the data set ready for ML. Okay, so we're just going to go to the raw version and copy that script and paste it into our run Python script and go ahead and select OK. Now, just to briefly tell you, Power BI will ask you about data privacy. Now, in this instance, we don't have any organizational rules to respect, so we're just going to ignore privacy levels for this purpose. Now, what we're doing here within this Python script for a very high level overview is we're just encoding all of our feature values to be In this instance, a decimal data type. The information that we're interested in is our df underscore imputed table. So when you do run Python scripts against Power BI, all of the data frames that you build in those Python scripts will be available to you. And in this instance, we're just interested in the df underscore imputed data frame, and we clicked table to expand that value. Now you can see here that we've encoded all of our values. So this is easily seen in marital status and gender, whereby instead of having, for example, single and married, we now have 0.0 and 1.0. Similarly, for gender, instead of having male or female, we now have 1.0 and 0.0. And this is key for us to be able to run the PyCaret library against these feature values. So once we've got the data prepared in this instance, we can go ahead and we're going to run our next Python script, which is going to build out our machine learning model. Okay, so we're going to go back to our GitHub repo. We're going to go to our second script, which is to train our data set for machine learning. We're going to get the raw version. We're going to copy that, its entirety, and we're going to paste that into. Now the key to be aware of here is that we're going to export at the end of this 2 files. One is the saved version of our model, which in this instance is a pickle object file, which holds our model object information. And also we're going to export the test data into a CSV as well. Now the key one that we're going to see in this session is going to be the use of our model pickle file. So go ahead and select OK. Again, the purposes of this session is to go through an overview as opposed to a technical deep dive. So we are glossing over a lot of the technical aspects of what we're doing here. Now, similarly to what happened on the service, when we trained the model, we set a time frame down to 5 minutes. Now, again, in the background, this will go away, train the model, and make that model available to us, and this will take some time. So with that being said, I'm just going to pick this up from a previously prepared version rather than wait for that information to continue. Okay, so I'm just going to go into an edit query in this version. Okay, and we're going to pick it up from what would be the output of that script. Okay, so once that script has finished running, as I mentioned, every data frame that we have in that script will be available to us. Now the data frame that we're interested in is the predictions table. So you would go ahead and select that table to expand it. And in this example, once you've expanded that, we can see here in our query preview, by scrolling all the way to the right, that we now have some additional columns. So you may remember previously in our sales training data, we had our buyer column, but now we have a label and a score. Now this is the same as the outcome that we saw in the Power BI service when we built our machine learning model. So our label is our outcome, so true or false if this individual will be a buyer, and our score again is the accuracy of that prediction based on the model. So great, we now have our machine learning model created. It's working as expected in terms of giving us back our predictions against our data, but now we need to get that to our lead data. So to do this, we have our lead data already loaded, and once again I'm going to pick this up from where it would have been in the previous script. So we would be at this step whereby we have our lead data loaded, and as I mentioned, we do not have a prediction against this currently. So what we want to do is go ahead, transform, and run our Python script, which will open up this screen. Okay, now this already has the script in it, but I will just show you which script you would need from the GitHub. Okay, so let's just go back to our root. So we're going to pick this up from obviously the next numerical script, which is number 3. So impute new data set for prediction. We're going to go ahead and get the raw version of this script. And then just before we do, I'm just going to take this back to the root. And then go back to our Power BI file in our Python script, and we would copy and paste. Okay. Now, once you're happy, you would just hit OK. As I mentioned, this is already run in this prepared version of the file. So I'm going to select cancel. Now again, very similarly to where we were in the last and the sales training data, we now have our 3 data frames. The one that we're interested in is df_imputed, and you would go ahead and select table here to expand this table. Once you've done that, it would open up this version, and as you can see, all of our values once again have been encoded to what would be decimal values, ready for us to run through our machine learning model in our Python script. So once this data has been encoded, you would go ahead, select transform from the ribbon and run Python script, and you will be greeted with another Python script box. Now finally, this script once again is available from the root of our GitHub, and it's number 4, which is pipe dataset for training. Now, interestingly enough, this is the smallest script we are going to use, but arguably the one that we're most interested in. So let's go ahead, select all of that information, go back to our Power BI, and again, this would be empty for you, so you would just go ahead and paste that in. Now, what we're doing here is we're calling our PyCaret library, we're using our classification model, and we're going to import everything from this directory. Now, this directory is where we stored, as I mentioned before, that pickle object, which stores our machine learning model object data, and we're then going to push our the data set that we've got here, so our lead data, through that machine learning model to get our predictions. Okay, so we're going to go ahead. And what this apply the model from the Power service. So once that's done, you would expand the table, which would bring you to our next screen. And this may take a moment, as I did apply that as opposed to cancelling the script. And if it does, then what I'll do is I'll just cancel out and just come back to this step so that we can see where it's already been applied. As I'm conscious, we need to have some time to take questions as well. Okay, so yeah, with that being the case, I'm just going to close that out and come back in. And to pick that back up to where it's already applied. So let's edit the query. Okay, so as I mentioned, you would go ahead and select OK on that script, whereby we would, in this instance, we should have pressed cancel as opposed to OK. So once that's run, you would expand the predictions data frame, and then we would scroll all the way to the right. And we can now see that for free within Power BI Desktop, we now have our label, so our outcome, and the score of that prediction, of the accuracy of that prediction, okay, applied to our lead data. Now, in this example, because we have encoded all of our values to mappings, to decimal values, we don't any longer have an actual textual first name or last name. So for the purposes of this demonstration, what I've gone ahead and done is just changed our data type for our buyer key to be an integer value, and I've just duplicated our original prospective buyer table and joined these two together so that we can actually get back to our first name and last name with an output. Similarly, again, you could merge these queries, you could bring them together however you see fit, but for the purposes of this demo, I just want to be able to show you the first name, the last name, and obviously the outcomes that we've generated. So in your example, you would go ahead and select close and apply to apply these transformations to your data. As I mentioned, in my example, this has already been done in an effort to save time and allow for this session. Okay, so with that being said, what we need to do, because we've joined these two lead tables together now, we can get our first and last name from our duplicate table so that we know that they're actual textual non-encoded values. And we can get our, let's just open this up, our outcome, so which is in this example our label. And we also need to get our score. Okay. Just going to make this slightly bigger. Okay, and then we're also going to put in a very rudimentary filter. And once again, similarly to how we did on Power BI Premium and Premium per user, we can go ahead and select those leads which our model has predicted to be buyers, and we can again sort these either descending or ascending via their score, so the accuracy of this prediction. And once again, we would be able to give this to our lead team, and potentially these leads would convert because they have a lot of similar attributes to what has been a buyer historically. Alternatively, we could also filter this to those values that our model has defined or predicted as not being buyers. Okay. So with that being said, that's a walkthrough of how we can use Anaconda and PyCaret to classify and predict our leads to be buyers or not within Power BI Desktop or Power BI Pro. So let's just jump back to our presentation. And we'll just go through and understand that we now have a vision. Okay, so here's how we can take it to a new level. We can use PyCaret to do outlier detection, topic distribution, potentially association rule mining as well, and all types of other data science and machine learning algorithms can be utilized using PyCaret as well. So with that being said, we do have more resources available to us. So a good friend of mine and fellow Microsoft MVP, Luca Zavarella, has an absolutely fantastic book called Extending Power BI with Python and R, and I would recommend that as a read. There's some fantastic websites available for data science, including KD Nuggets and Towards Data Science as well. And finally, obviously, we have the Anaconda website, and Microsoft has some great documentation as well in terms of using AutoML within Power BI. And finally, I'll just open up for any questions. So I'll just take a look within the chat. And excellent, doesn't appear to be any questions at the moment. So still mulling that over. As I mentioned, we went through quite a lot of information in quite a quick fashion to make sure that we stay on track within the session and deliver the content within the allotted time. But if you do want to reach out to me with any questions, then please feel free to contact me via LinkedIn. You can also come and see our website, onyxdata.co.uk. We would love for you all to come and join us at the Microsoft Power BI UK user group as well on LinkedIn. And also, please do come and join the Data DNA dataset visualization group, whereby we have a monthly challenge. This month, $200 of Amazon vouchers is up for grabs in terms of the best visualization based on a data set. So with that being said, I'd like to thank you all for being with us. I'll just stop sharing my screen. Okay, I'd like to thank you all for being with us. We do have one question coming in, and that is, how does the functionality compare with the AWS frameworks like Sagemaker? To be honest with you, it's probably not something that I can answer, having not used Sagemaker previously. I can say to you that the outcome is going to be pretty much, I wouldn't say the same. Obviously, you're building out a machine learning model to get your prediction, but I would say use the tools that you're obviously most comfortable with to get the job done. So in our example that we've been through today, we've used Python and some code. Now, not everybody in this day and age is happy or comfortable with utilizing code. So maybe AutoML tools like Microsoft's AutoML may be a good way to go. And there are similar offerings from other vendors as well. So hopefully that answers your question. Do we have any more questions at all before I close the session? Okay.
Thank you. It was a nice presentation.
Oh, thank you very much. That's greatly appreciated. I'm glad you all got something from it. And as I say, please do feel free to reach out to me on social media. We're very active and very happy to answer any questions there.
Sure, appreciate it.
Thanks, everybody, and also stay safe.
Thank you.